we did not. Yeah. Yeah. Well, I'm recording now, so we'll see if he watches this one. Hello, Liam. They're doubting whether or not you're going to watch this video. We got 110.569. Yeah, this is definitely a calculator problem. For your explanation, you would say V of t is positive for 0 less than or equal to t less than or equal to 110.569, which means the particle moves to the right on this interval. V of t is negative for t. Actually, I should not have an or equal to sign with that one because it is not positive at the point where it hits the x-axis. I think that's something they're not going to count off for, but should be perfectly correct. For t is greater than 110.569. So after not xt equals 110.569, the particle moves to the left. Therefore, the particle is furthest to the right at x equals 110.569. Okay, questions on that? I don't know. That's a good question. That's a good question. Probably we need it. I think the therefore symbol maybe is capitalized and we need a lowercase t there. I'm not 100% sure about the grammatical. She might know. She seems to know everything. She's smart. Yeah, it's a lot of writing. It's a lot of writing. All right. You at least don't have to cite your sources. And you get to draw symbols for a few words. Anyway, I could have done V of t is greater than 0. That would have saved me a little bit of writing there. Yeah. And less than 0 here. Should go back and fix that. I generally try to use as few words as possible, but this one's wordy. All right, let's look at this next one. It's hard. Okay, similar question. This time it's furthest to the left. We're looking at a particle moving on the x-axis, so that at any time t is greater than 0, its position is given by this equation. Now, this one gives us position. It does not give us velocity. We need to know velocity to know which direction that this particle is moving. So the first thing we're going to have to do for this is find the derivative here. So we are going to say x prime of t I'm going to go ahead and say equals v of t. You don't have to do that, but I like for it to be called v, so I'm remembering for sure I'm talking about velocity there. And then I'm going to use quotient rule for this. So I've got t times the derivative of the e to a t, and a is a positive constant. So derivative of e to anything is itself, right? So this is going to be e to the 2a t, but I've got to multiply by the derivative of that exponent. What is the derivative of 2a t? Because a is a number, we just don't know what number it is. It's not an extra, I mean, it is a variable, but we know that it represents a number, so we're going to call that 2a.
Doesn't t represent a number too?
Yes, but a represents one number that is not changing. T represents a variable that is changing. So A is like A is not really like much of a real world thing. They've just like put it in here to make you think about this more theoretically. Like what if A was not, you didn't know what it was. But T, we would be looking at plugging in different times for this. So that number would be changing. A is a constant number. We just don't know what its value is. So that's the difference in the two. They are both technically variables because, they represent a number that we don't know, but T can represent any number. A cannot. It's a single number. So that's your difference. All right. Minus e to the 2at times the derivative of the denominator, which is just 1 all over t squared. So that is going to be, since these both have e to the 2at's, I'm going to factor that out. So I'm going to have e to the 2at times 2at minus 1 all over t squared. Now, I need to know about the sign of this velocity. 2e to the at, always positive, right? E to the 2at, I'm sorry, I said that wrong. E to the 2at is always positive because e to anything is always positive. What about t squared? Always positive except at what number? 0. And this tells us that t is greater than 0, so we really don't need to consider that either, right? Really, that 2at minus 1 is the only thing that could possibly be positive or negative here. So if we solve this, we're solving it for t, we're going to get 2at equals 1. We'll divide by 2a. So t equals 1 over 2a. A is some number we know, we're not 100% sure. That would be positive because it told us a is a positive number. So on our line for velocity, we've got 0, we've got 1 over 2a here. And we've got to think about plugging a number in. Again, we could make us a chart, but e to the 2at is always positive. T squared is always positive. So really, this part right here, the 2at minus 1, is the only part that is going to give us different answers. So we need something between 0 and 1 over 2a. I think it's probably going to be negative, because if we plugged in 0, we would get a negative 1. But there's not an equal to right here with that 0, so we might want to be careful on that. What's something that would be between 0 and 1 over 2a?
1 over 4a?
1 over 4a would work. 1/2, it would depend on what your a value is. So maybe but it would depend on what that a value is. But if we do 1 over 4a, so like we do 1 over 4a right here, we're making that denominator bigger by multiplying it by 4, which makes its overall value smaller. So 1 over 4a is definitely going to work. So if we, we're definitely going to be between these two. So 2a times 1 over 4a minus 1 would be, that 2a's over 1, so that's 2a over 4a minus 1. Those cancel. We got 1/2 minus 1. That is going to be negative right there. Okay? What is something that would definitely be bigger than 1 over 2a? 1 over a. You want to be careful with doing just like a, because if it is a whole number, a is bigger than 1 over 2a, but a could be a fraction, in which case a is not bigger than 1 over a. So 1 over a is the best thing to use here. So if I plug that in, 2a times 1 over a minus 1, I would have 2a over a minus 1. A's cancel, 2 minus 1. You get a positive over here. And if my velocity is negative, what direction is my particle moving? And for positive, it would be moving right. So, this question asks us furthest to the left. That's going to happen at 1 over 2a. So we would have to say, since v of t is less than 0 for 0 less than t less than 1 over 2a, the particle moves to the left. On this interval. Since v of t is greater than 0 for t greater than 1 over 2a, the particle moves to the right. On this interval. Therefore, the particle is furthest to the left at t equals 1 over 2a. Okay. Questions? Yes. 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 So that, and in both of these cases, our critical point was our answer. It is possible to have more than one critical point there, in which case you got to think about it a little bit more and test some more stuff, which we'll see some of those come up later, I believe. If they do that, we'd have to know the original, like the actual values for the original. On these, because especially that last question we did, we didn't have the original problem. If they had given us one that switched more than once, we wouldn't be able to answer the problem. So right now, we're just looking at ones where they're only switching left to right or right to left. At one point, we'll see some in the future where we have to consider a couple more things. All right, questions? Okay. Let's look at 1 through 6 real quick. Because it's really like, it seems so minor, but just a slight wording change can cause your answer to be wrong whenever you're explaining things on these problems. So it's really important to think about. So let's see. Reagan, number 1, is that instantaneous or average? Yes, that is right. That is average because it's over a time period, not at a certain point. So where's mine? Let's see if this will work. Check this for. I might not be right on this. So average for that. Ooh, let's not use yellow. Okay. Let's see. 2. Lily, what do you think for 2? It is not. It is instantaneous. Although I can kind of see. I can kind of see why you would be inclined to maybe say average, but after 3 seconds is, at that point. Kind of gives away number 4, but like a different way that you could sort of say the same thing is number 4 is during the first 5 minutes. So it's not after it's done, which is a time point, right? It is a time period. So like during the first 5 minutes, that's going to be average rate of change. Really slight, like tiny slight wording changes can make your answer incorrect for this. Let's see. Kayla, what do you think about 3? Perfect. That is instantaneous. It is a specific time, not a time period. What if it said until noon? That would be average, right? Like you'd kind of need to know a starting point, but that would be average. Let's see. Jeremy, what do you think for number 5? Average is correct because it's over a time period, not a specific time. Miles, what do you think for 6? Yes, that is a one specific time, so that is instantaneous. Very good. All right, keep going. All right. Okay, for A of T, Luke, what have you got?
CM over CM over seconds.
Let's see. So you got CM over seconds. I don't think that works. Or does it? Centimeters times seconds over. No, that won't work. Your centimeters would cancel. You just get seconds. Unless, no, it won't work. Your centimeters will cancel. It will not work. There. This one is kind of weird because that centimeters is squared, which usually doesn't happen to us, right? Or hasn't yet. It will in some things. But it's always just changing y over changing x. So your independent variable, that is your x, and this is your y. So it's going to be centimeters squared per second. Which, when the seconds is squared, you can write it centimeters per second per second. But it doesn't work the other way around when the top number is squared. Okay. So it would just have to be centimeters squared per second. All right, Lucian, what have you got for the next one, the W prime?
Kilograms per cubic meter.
Kilograms per meters cubed. Perfect. That works. All right, last one's hard. Who thinks they have it? What have you got, Lydia? Okay. That is correct. However, it is not how you would report it because
Miles per hour.
hours per gallon. Because dividing fractions is easy as pie. Flip the second and multiply. And those miles will cancel and you will get hours per gallon for that. So that is what you would want to use, because if you were like writing a report about this, it would be very cumbersome to say miles per gallon per miles per hour, right? Whereas it would make more sense with it simplified there. But you were correct on what it should be. It just wasn't simplified. Okay. How far have we got? Have you guys got that next page done? Mostly. Not yet. Let's look at one at least. Oh gosh, we're about out of time. Yeah, let's do one and then I'll look and see what I'm doing. 3? Yeah. Let's do 3 instead. Okay. Alright, so A of t gives the acceleration in centimeters per second squared after t seconds. So A of 2 equals -6. That means after, what? 2 seconds. Oh gosh, I keep doing this. 2 seconds. The acceleration is -6. What are my units? Centimeters per second squared. All right, now the derivative of the acceleration is harder. So A prime of 7 equals -3 means that after, what goes here? 7 seconds. That's your time, or at 7 seconds. The acceleration is, what is happening to the acceleration? Decreasing at a rate of, what should I put here? 3 centimeters per second cubed. Because your units are going to be your units for acceleration, because this is the derivative. So, like if we're thinking of that acceleration graph, we got seconds here, and we got centimeters per second here, and we're taking the, or second squared here, we're taking the derivative of that graph. So it is centimeters per second squared divided by seconds, which is centimeters per second squared times 1/seconds, which is centimeters per second cubed. So, so that's what we'll get for that. All right, we are about out of time. Let me look at what's left. How about you guys do the next 2 pages for me, which it's not really numbered well for me to tell you. So do 1 and 2 if you haven't done them on this page, and then do this whole page right here and this whole page. So you can stop at that oil is being siphoned out of a tank question, that one that's called number 2, which the back side of that page really doesn't have any work on it. That leaves you don't have to do the very last page. We will do it probably at the beginning of class on Monday. So just a little bit on that to think about. Yes?
On this, I'm not like looking at like the difference between these, like to see
Right.
it's decreasing.
Right.
Just the sign.
Right. You're just looking at the sign. Yeah. 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 So if that derivative is negative, you're decreasing. If the derivative is positive, it'd be increasing. Right. Or you could say per hour. Wait, well, hold on. Because this gave us the area, our derivative one time. So this is correct. You have to record longer square per hour. So it would be if you were taking the second derivative that you didn't know what that is. So all depends on what you're starting with. So whatever your units here, so our units here are just so, and you take the derivative and divide it by that time one time.
Because it gives us
But,
two.
yeah, but here, this was giving us, like here we had centimeters per second squared. That was our original unit. So when we take the derivative, we've got to divide it by that time.
But if it just gave us like centimeters, then it would be
Centimeters per second, yeah. And then if we gave it centimeters per second, it would be squared. That tells you the amount of that function. So whatever that stands for. So like in this case, it was acceleration because A stood for acceleration. So this just tells us the acceleration is that amount. So it depends on what that stands for. So like here, where with your A, that gives the area of the whole, right? This gives area. So when you have A of 24 equals 17, it tells you that at 24 hours, the area of the whole set is 17. So it tells you that whatever that is defined as, when you take the derivative, it's the rate of change.
And then you can just like
Right. Yeah. Yeah. So whenever you're talking about whatever the original function it's just is whatever that value is. When you take the derivative, that's when you're thinking about like your change of y when you're changing x. Yeah.
I like the pictures that you pick up. I like how it's different.
Yeah. Yeah. That one AP had put that out, and I like it too. I think it's helpful.
It's more fun.
Yeah.
Can I ask you a question?
Yes.
For number two, like for one that you have
On this one, it really matters about like what signs you would have, because this particle would be moving to the left until it gets to 2, and then it will move to the right after that. So like if you think about where it's going, it starts off right here. There's A. It goes to the left first. There, that gets us to this point B where we switch, right? And then it goes to the right, and that gets you C, whatever that. So like this one was your X. So when you're trying to like think of the sign, that you put right left, this number is bigger than this number. So you need to do x of 0, x of 0. So that would be a positive number there. And then this number. Another way you could do it, and it doesn't matter what order, is instead of doing this. I'm like going crazy then, because like you could have absolute and out.
I don't know. I can probably try to do that.
And then we talk about but if it was fun, you could do it with absolute value bars, and then it wouldn't matter if it had those big numbers of 0, 2, and 2, 4, and then it would be correct. What did you need? You're welcome. All right. Oh gosh.